I am Dr. Ramanuja, Associate Professor, Department of Mathematics, Laxman Reddy Institute of Technology, Dundigal, Hyderabad. In previous modules, I discussed about Rolle's theorem and their geometrical interpretation, Lagrange's mean value theorem and geometrical interpretation, and also Cauchy's mean value theorem, and also expansions of functions at the Taylor series as well as the Maclaurin series. Further, I am going to extend the topic into these special functions, which is beta and gamma function. I am in the module of 3.5. I am going to cover beta and gamma function and their applications. Before entering into the beta special functions, let us talk about what is meant by a beta function, what is meant by a gamma functions, and also I am going to discuss about what is the improper integrals also in these modules. And also let us talk about the improper and integral. What is an improper and integral? An integral which is bounded by a to b f of x into dx, f of x into dx, where let us assume the function a equal to infinity and b equal to, so a equal to minus infinity, b equal to plus infinity. In between the values, this function is not finite, this function is not finite and also not bounded. Therefore, such a functions will comes under an improper integral. For this course, I am going to refer the textbook Higher Engineering Mathematics by B.S. Gravel and also J.C. Jain Engineering Mathematics, Higher Engineering Mathematics, this also course, and further some parts I am going to refer the textbook of S. Chand. Okay, let us talk about the gamma function and also beta functions. The gamma function and beta functions are then integrals, are special function and are considered as a generalization of the functions which involves the integral in different limits. When we talk about the special function, already I told an improper integral, that improper integral may be from integral 0 to infinity, because such a difficulty to evaluate that integrals. In such a cases, we are going to apply the gamma function as well as the beta function. And gamma function is defined as a single variable function. When we talk about the gamma function, we are treating as a one function for the calculating of the gamma function. And if you want to calculate the two variable function, I am going to apply the beta function. And together with these two functions, I can evaluate the values of that particular integral values, which are unbounded values. For this, lot of applications in engineering physics and also quantum mechanics, because unable to solve such a integral values, if we apply the special function, we can evaluate the finite value and also which is a bounded value in the case of the special functions. Let me talk about the definition of the beta function, and also I can extend the topic beta function further into gamma function. See, beta function is a two variable function where this gamma function is a single variable function. When we talk about the two variables, beta function is defined for the two variables, and also in this integral value evaluated in the 18th century, because this is an unbounded function. And beta function is an Eulerian integral. This also a first kind of the integral value defined from beta of m comma n integral 0 to infinity x power m into 1 minus x whole power n minus 1. This is called as the beta function. Beta function. This is always denoted by some cases they are writing in terms of capital B, or some notation they may use beta symbol also. That's what this function is represented in these two forms, which is, what is beta function? Beta function is where m and n are the positive integral values, beta of m comma n integral 0 to 1 x power m into 1 minus x whole power n minus 1. This is called as a beta function. See, for this beta function, it depends upon the values of m and n. This function will works under two. That's what I told about the beta function is a two variable function, whereas the gamma function is a single. Let me talk afterwards this completing of this beta function. We'll go with the gamma function. For this beta function, let us assume how this beta function is application in the engineering field. Actually, this beta function is an energy function. Beta function is an energy function, and also if you take any length of the wire, when we take the length of the wire, let us assume L, let this divide this wire into x, what will be the remaining part is 1 minus x. First part is x, 1 minus x. In such a cases, beta functions, when this integral values, when we take this value of L, which may be infinity to 0 to infinity, such a cases, we are going to apply the beta functions. Okay, let us go with the properties of the beta function. See, in the properties of beta function, already I told beta function. What is beta function? Beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x whole power n minus 1 into dx. This is the beta function. Beta function depends upon the values of m and n. M is and n always greater than 0. Let me talk about the first property of the beta function. Because we must have idea about the properties, we can apply these properties to solve the complex functions, complex integral functions. Let me talk about the beta. Beta of m comma n equal to beta of n comma n. This is called as a symmetric property. What is meant by the symmetric? Symmetric means what? If I take the m value and n value, both if you interchange the values will be the same. That's what is the first property? Beta of m comma n is equal to beta of n comma n. This is called as the symmetric property. If I write the definition of the beta function, I am not going to write always m comma n. That values we can interchange. Beta of n comma m is equal to integral 0 to 1 x power n minus 1 into 1 minus x whole power m minus 1 into dx. These are also possibilities of writing the symmetric function. Symmetric means we can share both the m values and the n values in the equal parts. This is the first property of the beta function. And also second property is called as an integral property of the beta function. Second property is called integral property of the beta function. Let us talk about the beta function. Beta of m comma n is equal to integral 0 to infinity x power m n minus 1 divided by 1 plus x whole power m plus n into dx. This is the one way we can write. If you see here, already I told in the first property, both m and n are the symmetric properties. M and n are the symmetric properties. What is meant by symmetric property? I can replace m, I can replace n. Whatever I like, interchange the function. That's what if I write integral 0 to infinity x power m minus 1 by 1 plus x whole power m plus n. This also possibility. What is the second property? Second property is called as an integral property. What is the integral property? Integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. I can rewrite integral 0 to infinity x power m minus 1 by 1 plus x whole power m plus n into dx. This is called as an integral property of the beta function. Okay, let me talk about the third property of the beta function. What is third property of the beta function, which is called as a trigonometric property, I can say. So what is the third property? Trigonometric property. How do you write the trigonometric property for the beta function? Beta of m comma n is equal to integral 0 to pi by 2 sine power 2m minus 1 into theta cos power 2n minus 1 theta into d theta. See, now we expressed in terms of what beta function, in terms of trigonometric function. What type of the trigonometric I used? Sine as well as the cos. How do you write the second? What is the third property? Beta of m comma n equal to 2 into integral 0 to pi by 2 sine theta whole power 2m minus 1 cos power 2n minus 1 into theta is called as the third property of the beta function. Okay, I told already symmetric property, we can interchange the m and n values. Let us go with the fourth property. What is the fourth property? I can add some values. I can say, if I write the third property, beta of m comma n equal to beta of m plus 1 comma n plus beta of m comma n plus 1. What I did in this property, I can given the some one unit term to the both first term as well as the second term. When we add these both the values, the resultant value becomes beta of m comma n. What is the fourth property? Beta of m comma n equal to beta of m plus 1 comma n plus beta of m comma n plus 1. This is the fourth property. You must have familiarized by these properties. We can apply these properties to solve the some unbounded function which are integral values may be 0. Here it is 0 to 1. We are treating in a beta function. Here beta function is a function of two variables m comma n. What is the first property? Is called symmetric property. Second property is called as integral property. Third property is called as a trigonometric property. Fourth property is called, we are adding the some m natural numbers m comma n by adding some 1 plus 1 unity values. The resultant value becomes what? Resultant value beta of m comma n. Let me talk about the, up to now what I discussed is a beta function. Beta function is a two variable function. Let me talk about the single variable function, which is called as a gamma function. Let me introduce the gamma function. See, gamma function, which is also known as Eulerian integral. This is also called as an Eulerian integral. This is second kind of the Eulerian integral. This is second kind of an improper integral, I can say. This is general form of the gamma function. If I write the definition of the gamma function, if I write the gamma function is a single variable function, which is also an second kind of the integral function. Therefore, gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 into dx. N is always greater than 0. Okay, let me write this definition. You will get the clarity. Gamma of n is equal to, what is gamma of n is equal to integral 0 to infinity e power minus x power n minus 1 into dx. We need to take n value is always greater than 0. See, now gamma is also, I told the representation of the gamma function is the symbol. This is the way of representation of the gamma function. This gamma function, integral 0 to infinity, see this gamma function, which is a function of n. In beta function, are you observed previously what we written? Beta is a function of m as well as n value. That's a two variable function. Gamma is a function of what? N. What is gamma of n? Integral 0 to infinity e power minus x power n minus 1 into dx. N is always greater than 0. Let us, these are the definition of the gamma function. What is the definition of the gamma function? Gamma n equal to integral 0 to infinity e power minus x power n minus 1 into dx, where n is greater than 0. Let me talk about, I am not going to say always n. Previously also beta, I can take instead of m and n, I can introduce the values of p and q. There is no difference because we need to take two variables. In this case, we need to take only single variable. Let me talk about the, I can say gamma of z. Is there any difference? There is no difference. Integral 0 to infinity e power minus x into x power z minus 1 into dx. Now we treat it as a single function, single variable as what? Z. We can introduce n or we can introduce z or any other variables also, but e power minus x power n minus 1 into dx. Let me take the value may be natural. Already I told n is always greater than 0. If I talk about gamma of 4, what is gamma of 4? Gamma of 4 is nothing but what? Integral 0 to infinity e power minus x. There is no change in their values of e power minus x power. What is the n value now we are treating? N equal to 4. If I substitute 4 minus 1, what is the resultant value? Integral 0 to infinity e power minus x power 3 into dx. This is nothing but gamma of 3. See, now whatever the value we are substituting, we will get the values of 1, 2, 3, like this we can calculate. Okay. Before going to the problem, I'll go with some properties like a beta function. Here also there is some properties. I can say first property, I am not going to prove all these results because you must have familiarized by, if you want to calculate suppose gamma of 1, there is a first property gamma of 1. What is gamma of 1 is 1. What is gamma of 1 is? Gamma of 1 is 1. See, if you want to prove this result, take this definition of the gamma function, substitute n replaced by 1 and integrate, the resultant value becomes how much? 1. This is the, you can prove this result. Gamma of 1 equal to how much? 1. And the second one, gamma of n plus 1 can be written as n into gamma n, or I can say n factorial. How do you write gamma of n plus 1? What is second property? Gamma of n plus 1 equal to n into gamma n into n factorial. This is a third property, and I can rewrite one more property about the gamma function. Gamma of n can be written as n minus 1 into gamma of n minus 1. Suppose if you want to calculate further gamma of n minus 1, you can substitute n replaced by n minus 1. We will get the like these terms. Okay. And third condition, what is the third condition? Gamma of n equal to gamma of n plus 1 divided by n. Now we will talk about the, this is the special case of this property. See, suppose this function, what is the third property I wrote? Gamma of n is equal to what? Gamma of n plus 1 divided by n. See, for the, what I told n is always greater than 0. Suppose you need, in this property, if I say n is always not equal to 0 now, I am coming across with the n is not equal to 0. For this case, there is a gamma function. Gamma function, there is some certain values, there is a discontinuity. In such a cases, we need to calculate their negative values also, we can calculate gamma. Okay, this is about the property. We must remember this property as gamma of n equal to gamma of n plus 1 divided by n. And one more property which is called as gamma 1 by 2. Suppose if you want to prove this result, use the trigonometric beta function and put n equal to 1 by 2, m equal to 1 by 2, and based on that, using the relation, we can calculate the gamma of 1 by 2. What is gamma of 1 by 2? Root pi by 2. Okay, these are the basic properties of the gamma function. What is the definition of gamma function? Gamma n equal to integral 0 to infinity e power minus x, x power n minus 1 into dx, where n is greater than 0. Okay, and what is the first property I told? Gamma of 1 is 1, gamma of n plus 1 is nothing but n into gamma n. I can rewrite n factorial gamma of n equal to n plus 1 divided by n. I can say gamma of 1 by 2 equal to root pi by 2. These are the basic properties of gamma function. We will use these properties. I can evaluate some special functions like applying the beta as well as the gamma functions. Okay, let us look the first example problem. Evaluate integral 0 to 1 x square into 1 minus x whole power 4 into dx. When you observe this function, this function looks like a beta function. Looks like a beta function. Okay, let us solve the function. First function, integral 0 to 1 x square into 1 minus x whole power 4 into dx. For this function, I can rewrite integral 0 to 1 x square is there. X square can be written as what? X power 3 minus 1 into 1 minus x whole power 4 is there. I can write 5 minus 1 into dx. Now look the definition of the beta function. What is the definition of beta function? Beta of m comma n is equal to integral 0 to 1 x power m minus 1 minus x whole power n minus 1 into dx. Now I can compare these values. I can compare these two values. What is the value of m now? M is equal to represents 3. What is the n value represents? 5. Now this value integral 0 to 1 x power 3 minus 1 into 1 minus x whole power 5 minus 1 into dx written as beta of 3 comma 5. Beta of 3 comma 5. See, for this value we need to calculate beta of 3 comma 5. Okay, let me go with their one property of the beta function. One more property I can use. See, beta of m comma n value, if m and n are the both positive integer values, we can express m minus 1 factorial into n minus 1 factorial divided by m plus n minus 1 factorial. This is the property of beta of m comma n. We can use this property, we can substitute m value, we can calculate the value of 3 comma 5. Okay, this is about the, but I am not going to apply, I can apply the relation between beta and gamma for this value calculation of 3 comma 5. Okay, this is about the beta of 3 comma 5. Further class, I am going to calculate beta of 3 comma 5 value, or we can use this result m minus 1 factorial into n minus 1 factorial whole divided by m plus n minus 1 factorial. Okay, this is about the second function. Look the example 2. Example 2 shows that integral 0 to infinity x power 3 divided by 1 plus x whole power 4 into dx. See, already we discussed about the property of beta function in the form of the integral values. Okay, what is the, I can rewrite this one, consider integral 0 to infinity x power 3 whole divided by 1 plus x whole power 4 into dx. I can rewrite this value integral 0 to infinity x power 4 minus 1 whole divided by 1 plus x whole power 3 plus 1, 4 plus 1. I can rewrite what is the denominator value? 4. 4 can be written as what? 3 plus 1 into dx. 3 plus 1 into dx. See, for this integral value, I can write the property of beta function in integral form. Beta of m comma n is equal to integral 0 to infinity x power n, or you can use m, x power n minus 1 whole divided by 1 plus x whole power m plus n into dx. This is the property. From this result, I can compare the values of m and n. What is m value? M value represents 1 and n value represents n value is 4, m value is 1. I can rewrite m plus n. This is nothing but what? Beta of 1 comma 3. Now we can calculate beta of 1 comma 3 value by using the condition beta of m comma n is equal to m minus 1 factorial into n minus 1 factorial whole divided by m plus n minus 1 factorial. Otherwise, we can use the relation property, we can calculate the beta of 1 comma 3 value. Okay, this is the second example problem. Further, I am extending one more property of the beta function. Okay. So, problem number 3, evaluate integral 0 to pi by 2 sine power phi theta into cos power 3 theta into d theta. For this, we need to express this value in terms of what? Beta and gamma functions. Okay, this is about what is this function? This function is a beta function in terms of what? Trigonometric values. Okay, let me write the what is a given question, what is a given problem? Integral 0 to pi by 2 sine power 5 theta into cos power 3 theta into d theta. What is the trigonometric form of the beta function? Integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta equal to 1 by 2 into beta of m comma n. Beta of m comma n. Now we are going to compare the powers of these values. What is the resultant value here? 2m minus 1 is equal to 5. 2m equal to 5 plus 1. 2m equal to 6. M value becomes how much? 3. Similarly, we can compare 2n minus 1 equal to how much? 3. 2n is equal to 3 plus 1. 2n is equal to 4. N is equal to 2. What value we got? M and n value. See, this integral value can be expressed what? In terms of beta functions. Integral 0 to pi by 2 sine power 5 theta into cos power 3 theta d theta is equal to 1 by 2 into beta. What is beta value? M value is 3. What is n value? N value is 2. Now we express entire trigonometric value. We express entire trigonometric beta function. We express what? 1 by 2 into beta of 3 comma 2. Okay. Further, beta of 3 comma 2, we are going to use the relation. We can calculate the beta of 3 comma 2 value. Further, we can apply this result. Further, we can apply this trigonometric function. I am going to prove 1 by 2 into beta of second property. Show that the integral 0 to pi by 2 sine power p theta cos power q theta d theta can be expressed as 1 by 2 into beta of p plus 1 by 2 comma q plus 1 by 2. This is the second property. If you want to prove this result, we will use only continuous process of the trigonometric function property, beta function in terms of trigonometry. What is the beta function trigonometric property? Integral 0 to pi by 2 sine power 2m minus 1 theta cos power 2n minus 1 theta d theta equal to 1 by 2 beta of m comma n. We need to calculate m comma n. See, if I compare 2m minus 1 value with p, 2n minus 1 value compare with q. Therefore, 2m minus 1 is equal to p and also 2n minus 1 is equal to q. 2m minus 1 equal to p plus 1, 2n equal to q plus 1, m equal to p plus 1 by 2, n is equal to q plus 1 by 2. Now we got m and n value. Now I am going to substitute entire, wherever m is there, I am going to substitute p plus 1 by 2, n is replaced by q plus 1 by 2. Let me substitute this value, integral 0 to pi by 2. What is 2m minus 1 value? Sine power p theta into 2n minus 1, which is nothing but cos power q theta, d theta equal to 1 by 2 into beta of, what is m value? M is nothing but what? P plus 1 by 2. What is n value? Q plus 1 by 2. Now we got the value of this integral values. Integral 0 to pi by 2 sine power p theta cos power q theta d theta equal to 1 by 2 into p plus 1 by 2 q plus 1 by 2. Similar manner, we can take whatever the n value. Suppose I can't say always p. I can take p instead of p. I can use n minus 1. I can use m minus 1. Similar procedure we can derive this result like this. Okay, this is about the problem number 4. And one more problem, I am going to extend this beta function in the integral form. Okay, look this, evaluate the integral 0 to infinity x power 3 minus 1 minus x power 5 divided by 1 plus x whole power 13 into dx. Okay, now let us simplify this integral value, integral 0 to infinity x cube into 1 minus x power 5 whole divided by 1 plus x whole power 13 into dx. How do you write this one? Integral 0 to infinity x power 3 minus x power 8 divided by 1 plus x whole power 13 into dx. This can be written as integral 0 to infinity x power 3 whole divided by 1 plus x whole power 13 into dx minus integral 0 to infinity x power 8 divided by 1 plus x whole power 13 into dx. Now I separated all the integral values into separate. Now look the beta function in the form of integral. Let me talk about the beta function in the form of integral. Beta of m comma n is nothing but what? Integral 0 to infinity x power n minus 1 by 1 plus x whole power m plus n into dx. This is the beta function. Now I can express integral 0 to infinity x power 4 minus 1 divided by 1 plus x. How do you write this 13 value? 4 plus 9 into dx minus integral 0 to infinity 8. 8 can be written as x power 9 minus 1 by 1 plus x into 13 can be written as 9 plus 4 into dx. Now look these values. What is m represents? You can interchange, because this is symmetric property. We can interchange m as well as n. Not only I am not going to write always n, I can use m also. Okay, this is nothing but beta of 9 comma 4 minus beta of, I can rewrite 4 comma 9. Already we know the symmetric property, beta of m comma n equal to beta of n comma m. Okay, I can rewrite beta of 9 comma 4 minus beta of 9 comma 4. What is the resultant value? The resultant value becomes 0. Therefore, this integral value is 0. Okay, this is the similar manner we can extend all the functions. Okay, let me talk about only definition of the beta function. What is the beta function definition? Beta of m comma n equal to integral 0 to 1 x power m into 1 minus x whole power n minus 1 into dx. n minus 1 into dx. This is the definition of the beta function, which is a two variable function. When we talk about the gamma function, gamma n equal to integral 0 to infinity e power minus x power n minus 1 into dx, where n is a single variable function. I hope now it is clear about the definitions of beta function and simple example problem I taken to solve this class. Okay, thank you.